In many videos you can see till today, I used the so-called field of statistics or data science of supervised learning. It is used to explain a phenomena because we can link the phenomena to a known variable inside the dataset. In this video, the variable can just emerge with a different approach, called not supervised. And generally, psychologists and economists use this approach to find out variables they can't measure directly, from sexless people to freedom of speech. In companies, sometimes the customer journey doesn't look clear at all, and this learning technique can, in the presence of the right data, enlighten an important piece of the meeting between offer and demand. We have this request where the main objective is to describe the main personas within the user behavior provided in a dataset, and the user behavior cannot be named automatically. Let's give a look to the dataset. We have 34 columns and over 100k rows. The names of the columns don't really explain much, and unfortunately we also don't have the data documentation. But let's go to do some descriptive statistics first. First of all, you notice that out of those huge amount of rows, we have a lot of holes. That means few columns have a complete series, and of course, when we have so much missing data, it becomes a problem. Now let's see the distribution of the most complete variables that you can see also here, and in one case it is an exponentially negative distribution, and in the other case it looks the same, but it can get confused for a binomial distribution. So we have a lot of holes, difficult distributions to manage. If we had a normal situation of classification, especially with a quantitative target variable, those two elements would have created problems. But here the context, it is different. Now I will use a statistical model that I rarely use because, as I said, I generally do supervised learning. And this model does clusters, and so the clusters are the personas the persons ask for. Let's see though how this model works, because I don't have much experience with such models, because such kind of requests are quite rare. If we go into the E of JASP, we see in the assumptions that we have one condition that is similar to the regression model. That means we must have normally distributed data, because it aids the creation of the clusters, in this case the personas. So you see from here that we do not meet this condition. So if we don't, we start with a problem, because we already saw from here we had the one of the distributions. Notice how few observations it actually uses compared to the ones we had here. The R squared is something that you already saw in other videos, and it is something also more familiar to me, and it is the variance explained by the clusters. But in the other videos it was the variance explained for the target variable, and I remind you that the variance is the average oscillation from the average of the target variable. So we want to explain them. That is statistics. When we don't have oscillations from the average. We have a constant and we don't need statistics to explain that variable. In this case, it is not the explained variable on the target variable because we don't have one, but on the clusters. So it is different. Then we have a complexity parameters that is high. Of course, we could reduce it. And then we have the silhouette, something that really belongs to this kind of models. And the silhouette has its own interpretation compared to the R squared. Remember that here you want to separate clusters, so personas. This number indicates that we don't have a very good model that separates the clusters, because this index has a domain that goes from -1 to 1, where 1 is the best score in these terms. Down you see the cluster information, and you see that some clusters have a higher silhouette score than others. This could indicate that we might need more or less clusters. And here you can see we can select the maximum amount of clusters. If we put, for example, 8, and this will take time, because I remind you that we deal with a lot of rows, and in JASP such amount of rows can classify as big data. We see that the silhouette doesn't really change much, and also the explained variance. You can see more clearly with this kind of plot. It doesn't look we can really find personas for the kind of data we have, also because, again, we use a very small subset of the original data, because we have a lot of missing data, and we don't know why, because we don't have the data documentation, so we don't know the data quality. We can try another algorithm, random forest clustering, to see if things improve, and the answer is no, also because we have a negative value and a lower explained variability. Here we can see one chart that helps us to select the optimal amount of clusters, and here is the, let's call, the automated way to select them. I would personally stop at 4, but again, you see a very messy image that really doesn't answer our question. We can try to put a fixed amount of clusters also here to see if something changes. This slightly improves, but the answer is basically no. Here you see something that I discussed also in other videos, that is a descriptive index for selecting which variables to put to create, in this case, the clusters. As a conclusion, as you saw, even though we have a lot of data, apparently, we can't answer the question, and this might sound, understandably, disappointing. And unfortunately, this can happen in statistics, or more broadly in science, as I also highlight in other videos. If you want to find a hidden variable or cluster in your company that works as a pattern for one of your key performance indicators, you can contact me on the contact page of www.staticalmo.com, and you will see a button where you can book a call where we will discuss your case. Of course, you could say that the negative answer of this video could also depend on the personal limits I have at the moment on those kind of tools. But anyway, bye and see you the next time.